Welcome to the lesson on calipers and micrometers. By the end of this lesson, you will be able to identify common precision measuring tools used in aviation maintenance and differentiate between types of calipers and micrometers based on their applications. You will be able to read and interpret measurements accurately using both calipers and micrometers, including understanding scale markings and measurement increments. You will also apply proper techniques when using micrometers to ensure accurate and repeatable results. Finally, you will be able to describe the correct care, handling, and limitations of precision measuring tools to maintain their accuracy and reliability in aircraft maintenance operations. Accurate measurement is fundamental to aviation maintenance, where even small deviations can affect safety and performance. Precision measuring tools are used to verify that components meet specified tolerances during inspection and maintenance. Unlike general measuring tools, these instruments provide higher accuracy and repeatability, which is critical when working with aircraft parts. They are used to obtain direct measurements or compare dimensions against known standards. The tools introduced in this lesson, including calipers and micrometers, support quality control and ensure airworthiness. The visual shows typical examples used in maintenance environments, highlighting the variety of configurations available for different measurement needs. Here are the different tools covered in this lesson. Basic calipers are primarily used for comparing dimensions, while slide calipers provide direct readings for a wide range of measurements. Micrometers are used when higher accuracy is required, particularly for critical components. Vernier micrometers extend this capability further by allowing measurements to the 10,000ths of an inch. Each tool type is designed for specific applications, and selecting the correct tool depends on the level of accuracy required and the geometry of the part. Starting with the simplest tools, basic calipers are used to measure and compare internal and external dimensions. Unlike slide calipers, they do not provide direct readings and must be transferred to a scale or rule for measurement interpretation. Outside calipers measure external diameters, while inside calipers are used for internal dimensions. The hermaphrodite caliper serves a different purpose, functioning as a layout tool for marking lines. These tools are commonly used for quick comparisons rather than precise measurements. Their simplicity makes them useful in preliminary inspection tasks, but they're not suitable when high accuracy is required. Slide calipers are designed to measure inside, outside, depth, and step dimensions using a single instrument. The three common types are vernier, dial, and digital calipers. These differ primarily in how the measurement is displayed. Vernier types require scale alignment, while dial and digital versions simplify reading. These tools typically provide accuracy around plus or minus 0.001 inch. The jaws are used for internal and external measurements, and the depth rod is used for depth measurement. Because readings are direct, there is no need to transfer measurements to a rule. This reduces error and improves efficiency in maintenance tasks. Since slide calipers provide direct measurements, it is important to understand how to read them correctly. Vernier calipers use a main scale and a sliding vernier scale to determine the measurement. The main scale provides the base value, and the vernier scale adds precision. Dial calipers use a pointer to display the measurement on a circular scale. Digital calipers provide a direct numerical readout. Before taking any measurement, the tool must be zero. This ensures accuracy and repeatability. The jaws must be properly aligned with the workpiece. Misalignment can introduce measurement errors. Proper handling of calipers becomes essential for maintaining accuracy. Calipers must be kept clean to prevent debris from affecting the measuring surfaces. Dirt or damage can lead to incorrect readings. Excessive force should not be applied when closing the jaws. This can distort both the tool and the measurement. Calipers should never be used as prying tools. This can permanently affect their accuracy. The tool must be checked for zero before each use. Proper storage protects the tool from damage. When measurement accuracy requirements increase, a more precise tool is needed. Micrometers are designed to provide measurements with higher accuracy than calipers. These tools typically measure to 0.001 inch, and vernier micrometers can measure to 0.0001 inch. They are used for measuring thickness, diameter, and depth of components. Micrometers are manufactured in specific size ranges, such as 0 to 1 inch or 1 to 2 inches. The correct size must be selected before measurement. The visual shows an outside micrometer, which is commonly used in aviation maintenance for critical measurements. Because different measurement tasks require different approaches, several types of micrometers are used. Outside micrometers measure external dimensions, such as shaft diameters. Inside micrometers are used for internal diameters of holes and bores. Depth micrometers measure the depth of recesses and slots. Thread micrometers are used for measuring thread dimensions. Digital micrometers provide direct readouts for easier interpretation. Each type is designed for a specific application. The outside micrometer is the most commonly used type in maintenance work. It is used to measure shaft diameters, sheet thickness, and tool sizes. Micrometers provide greater accuracy than calipers and standard rules. The standard rule measures to approximately 1/64 inch. Micrometers measure to the thousandth of an inch or finer. Despite differences in design, all micrometers operate using the same reading principle. This makes them consistent and reliable tools across various applications. To understand how micrometers achieve precision, the main components must be identified. The frame provides structural support and maintains alignment. The anvil is the fixed measuring surface. It forms one side of the measuring gap. The barrel, also called the sleeve, contains the measurement scale. It also houses the internal threads that guide spindle movement. These fixed components provide stability during measurement. The label diagram helps identify each part and its role in the measuring process. In addition to the fixed structure, the moving components control how measurements are taken. The spindle moves toward or away from the anvil to adjust the measuring gap. The thimble is rotated to move the spindle through threaded motion. The ratchet stop applies consistent measuring pressure. This prevents excessive force that could affect accuracy. These components work together to produce precise and repeatable measurement. The diagram shows how each part contributes to the measurement process. Let's now take a look at how to read a micrometer measurement. The sleeve or barrel displays a main scale, including tenths of an inch and increments of 0.025 inch. Each visible line represents 0.025 inch. The thimble provides additional precision in increments of 0.001 inch. One full rotation of the thimble moves the spindle 0.025 inch. The total measurement is obtained by combining the sleeve and thimble readings. The diagram illustrates how these scales align to form the final measurement. The reading process begins by identifying the base value on the sleeve. The last visible number represents the tenths value. This establishes the starting point of the measurement. For example, if the number 1 is visible, the base value is 0.100 inch. This value must be identified before adding additional increments. The visual demonstrates how to locate this value accurately. After determining the base value, the next step is to count the sleeve divisions. Each visible division represents 0.025 inch. These divisions are added to the base value. For example, 2 divisions equal 0.05 inch. Only fully visible lines should be counted. Partial lines must not be included. This step ensures intermediate values are correctly accounted for. With the sleeve values determined, the thimble reading provides the final level of precision. Each division on the thimble equals 0.001 inch. The align marking indicates the value to be added. For example, a reading of 10 equals 0.010 inch. This step captures the fine measurement details required for accuracy. The final measurement is obtained by combining all values from the previous steps. The sleeve value, division value, and thimble value are added together. For example, 0.100 plus 0.05 plus 0.010 equals 0.16 inch. Each value must be verified before recording. Any misreading can result in measurement error. For applications requiring higher precision, vernier micrometers are used. These tools measure to 0.0001 inch. A vernier scale is added to the sleeve. The aligned marking between the vernier and thimble determines the additional value. This allows for very fine measurements. These tools are used in high tolerance applications where standard micrometers are not sufficient. Accurate measurement depends on proper technique. A micrometer must be held securely, typically with the frame resting in the palm and the thimble operated using the thumb and forefinger. This ensures stability during measurement. The workpiece should be placed squarely between the anvil and spindle to avoid angular error, which can lead to incorrect readings. The spindle is advanced toward the workpiece, using smooth, controlled rotation of the thimble. Final contact must always be made using the ratchet stop. This is critical because the ratchet applies consistent measuring force, eliminating variation caused by excessive hand pressure. Over-tightening can distort both the tool and the part, especially with softer materials. The measurement should feel firm but not forced. Once the spindle contacts the part using the ratchet, the reading should be taken immediately to avoid thermal expansion effects from prolonged contact. Maintaining the micrometer's accuracy is equally important. Micrometers are precision instruments and must be handled with care at all times. Dropping the tool can misalign internal components, leading to permanent measurement errors. The measuring faces, including the anvil and spindle, must be kept clean and free of dirt, oil buildup, or burrs. Even small contaminants can significantly affect readings. Before and after use, the measuring surfaces should be wiped clean. Excessive force must never be applied during measurement, as this can distort the frame or damage the threads. The micrometer should not be used on moving or rotating parts, as this can cause wear or inaccurate readings. After use, the spindle should be slightly open to relieve pressure on the threads. The tool should be stored in a protective case to prevent damage and exposure to environmental conditions. Proper care ensures long-term accuracy, reliability, and consistent performance. Finally, let's compare the use of calipers and micrometers to clearly understand when each tool should be selected in aviation maintenance. For general measurements, calipers are commonly used because they are fast and convenient, making them suitable for quick checks and routine tasks. However, when high precision is required, micrometers are preferred due to their greater accuracy and finer resolution. Calipers typically provide moderate accuracy, around plus or minus 0.001 inch, while micrometers can achieve higher precision down to 0.0001 inch with vernier scales. Both tools can measure inside and outside dimensions, but they require the correct type, such as inside or outside micrometers. For depth measurements, calipers use a depth rod, while depth micrometers provide more precise results. In practice, calipers are often used during initial measurement or fitting because they are easier to handle and quicker to use. Micrometers, on the other hand, are used for final inspection and tight tolerance verification, where accuracy is critical. Although micrometers require more skill to operate correctly, they provide the level of precision needed to ensure components meet strict aviation standards. Let us now summarize what we have learned in this lesson. Precision measuring tools are essential for ensuring accurate dimensions and compliance with specified tolerances in aviation maintenance. Basic calipers are used primarily for comparison measurements of internal and external dimensions, while slide calipers provide direct readings for inside, outside, depth, and step measurements. Micrometers are used for high accuracy measurements of critical dimensions. Accurate results depend on correct reading techniques and proper tool usage. Proper care and handling are necessary to maintain the accuracy and reliability of these precision measuring tools. Thank you for your attention.